So today, really, we're talking about radians. Radians as an angle and as an arc length. Okay? It's both. So, first of all, 80 degrees. So 80 degrees, remember, degrees are for dummies. We can convert that. So if I go to my unit circle just real quick, 80 degrees is probably right about here, right? So pi thirds is here. So there's another pi something or other that's right about here. It would be the same as 80 degrees. Does that make sense? Let's find out what it is. So we use our formula. So we go to our notes, and we're going to convert degrees to radians. We're going to use our notes, right? So we're going to use this formula. We're going to use the d over 180 pi, and we'll get a radians. So d is 80. So we're going to just rewrite this as 80 over 180 pi. And if you cannot do fractions, hallelujah, calculators can do it for us. So if I can't do fractions, I'm just going to go ahead and go, all right, 80, you want to see this cool thing? 80 divided by 180, and it should be, 8 18ths, 4 ninths, it should be 4 ninths. If you can do fractions, but if you can't, where do you think the fraction button should be? In the math button, right? Fraction button should be in the math button. So I go to math, there's fraction, boom, reduces it to 4 ninths. Now, hopefully you know how to reduce fractions. I don't know, I didn't teach you fractions back in 6th grade, but maybe you do. So I reduce this to 4 ninths pi. That is the radian equivalent to 80 degrees. That makes sense? It's easy. Now, B is a little bit different because we're not going to be able to get this into a fraction in terms of pi. I like it in terms of pi, but when it's got 48 degrees and 36 minutes, then I'm probably going to get a decimal. Remember, decimals are okay. Check it out. 3.14. That's a decimal, right? It's still an angle on the unit circle. So we're probably going to get a decimal answer on this one. So before I do anything, 36 minutes is kind of like the clock. So there's 36 sixtieths, right? So as a decimal, 36 divided by 60, that's 0.6. Okay, so I'm just going to change this first right off the bat to 48.6 degrees. You okay with that? So I just changed the minutes into a decimal. I know there's 60 minutes in 1 degree. And so then let's use my formula. So my formula is this formula right here. We're going to use our degree over 180 times pi. So I'm going to go, okay, I can do that. 48.6 over 180 times pi. Now, I'm not going to worry about getting this in terms of pi. I'm just going to get an ugly decimal. It's still the answer. So I'm going to go, okay, what is? See my calculator, what is? 48.6 divided by 180 times pi. I get about 0.84. Okay, 0.848 radians. Now, let's go back to what that means, right? We said 57 was about 1 radian, right? Didn't we say 57? So 48.6, that makes sense to be a little less than 1, right? So the angle actually makes some sense. If you're with me, okay? All right, now, number 2, we're going to convert the other way. So this is in terms of radians. We want to go to degree. So I go to my formula. There's my little formula, radians, 2 degrees. There it is. So we're going to go, all right, R times 180 over pi. Let's put our 3/5 right there. So I'll rewrite this as 3 pi fifths times 180 over pi. We're just using a conversion. That's all. The conversions are in our notes. So I put my radians right there. This is my conversion that we got out of my notes, out of my reading. Pi's cancel, right? And I'm just going to use my calculator. And I'm going to go, okay, 3 times 180 divided by 5. And I get an answer about 108 degrees. So 3 pi fifths. You get your pi thirds, pi halves. 3 pi fifths is right about here for 108 degrees, right? Okay, so they're the same. Degrees, radians. They're both angles, okay? Now, 4.5. Well, 4.5 is a radian, but the pi is not there, right? So let's still use the formula. So the formula is that formula right there, right? So let's put our 4.5 in for the radians. So okay, I can do that. 4.5 times 180 over pi. The pi's won't cancel, right? So I'm going to get a decimal. I can live with a decimal. I really can. If I can live with 3.14, I can live with a decimal, okay? So 4.5 times 180 divided by pi, okay? I get about 257.83 degrees. 257.83 degrees. Now, if I want to change, and you can just watch this, it's actually pretty easy. If I want to change that to degrees and minutes, there's a cool button. Probably where the angle button is, there's this thing called a DMS. What do you think that stands for? Degrees, minutes, seconds. So you can take that answer and change our 257 degrees, 0.8, and I hit that. So it's really 257 degrees in about 49 minutes, okay?
How did you get to that button?
I'll show you again. Okay? So what you do, I'll go right through, okay? So we'll get, let me go back to the answer, 4.5 times 180 divided by pi. Okay, now, that's an angle, isn't it? Do you agree that's an angle? Well, let's find our angle button. Where's our angle button? Right there. So go to blue, angle, and DMS. DMS can mean a lot of things, but in the angle button it means degrees, minutes, seconds, okay? Change it to degrees, minutes, and seconds, so it's really 257 degrees. Have you ever seen this like on maps, right? You guys have seen this on maps, where they take on a map and they have it divided into degrees, minutes, and seconds. That makes sense? Okay. All right, moving on. Example 3. Find the arc length of an arc with a radius 10 and central angle is 40. 40 degrees. I want to circle the degrees. I want to put degrees. So I go to my notes. Arc length. So I got this arc length formula here and this one. This one's in degrees, right? This one's in radians. So I'm going to use the one that's in degrees, right? Because this is 40 degrees. So I'm going to go, okay, S equals theta over 360 times 2 pi r. Do you mind if I simplify this formula just a little bit? Because honestly, the 2 and the 360 are kind of bothering me. It's a little bit simpler. I just write it as theta over 180 pi r. Same formula, but I just reduced the 2 and the 360. You okay with that? Just one less number to deal with. So let's use it. So in this case, S is equal to 40 over 180 times pi times 10, and I'm going to use my calculator, okay? So, alright, I'm going to go 40 divided by 180 times my pi times my 10, and I get an answer of about 6.98, and that is in terms of centimeters, okay? That's a practical number, because what do we just find? Okay, they're building us a school out there. I don't know how many arcs they're going to build, but I mean, if they did have something like this and they needed this arc length so they could make a board or something, right? They'd need to find out how long it is. If this is 40 degrees, guess what? That's going to be about 6.98 centimeters, okay? So it's really pretty practical math, isn't it? I mean, you know, you might need to know the length of that. I know in track, we actually we do. In track, you actually need to know the length of the toe board, and same thing in discus, you need to know the length of the foul. We actually do. Okay, example 4. Find the central angle that subtends an arc of 6 centimeters and has a radius of 5, a radius of 4. Okay, so now, first question.
What is subtend?
Subtend means it's the arc that is on it.
Okay.
Does that make sense? It's the arc that's on it. So here's our question. It's up to you. We can get our angle in 2 ways. 1, degrees. 2, radians. Our angle can either be in radians or degrees. What do you want to do? Degrees or radians?
Radians.
Why do you like radians? Because it's easier. See the formula? So if we wanted to use the degree one, we'd have to use this formula. If we want to use the radian formula, get this one, even though our theta will be in radians. Okay, so let's use this one. Heck yeah. So let's use our S equals our theta. Now we need to find theta. So we'll put our radius is 4, our arc length is 6, we'll go 6 equals 4 theta, okay? I'm just going to put the 6 for the arc length. That's a 6, doesn't look like a 6. We'll use our 4 for our radius, right? Divide. 6 divided by 4 is about 1.5 theta. Now, that doesn't look like an angle, right? Doesn't look like an angle at all, right? But it is 3.14. So 1.5 is around, well, that's about 1.57, right? So it's right about there. It's pretty close to the 90 degree angle. It's pretty close, okay? It is an angle. It doesn't look like an angle, does it? 1.5. But if 3.14 can be an angle, so can be 1.5, right? Okay, turn the page. We're getting there, okay? Okay, the area of a sector of a circle with central angle 40 degrees and radius. Okay, so area. So first of all, draw a picture so you get the idea. Real quick little picture. 40 degrees, radius is 4. And what I want is the area. So I want the pizza. I want to eat the whole slice of pizza. I need the area of that, right? So what do? Well, I'm going to use, I've got two formulas, right? Which one am I going to have to use? Two formulas. Which one do I have to use? I got to use the ugly one, right? Because it's degrees, right? So I have to use the ugly one. So I'm going to use A equals my theta over 360 times pi r squared, right? I'll put my 40 in there. So I'll go, okay, area is equal to 40 over 360 pi times 4 squared. And I'm just going to use a calculator, okay? So this isn't that hard. You just plug in numbers into a formula, right? All right, so we got 40 divided by 360. Yeah, thanks, Marie. 40 divided by 360 pi times 4 squared. I get an answer about 5.58, and that would be in terms of its area, in terms of centimeters squared, because there, okay? So that's how much pizza I get to eat, okay? As far as area. Okay, example 6.
We should have a pizza day and then call it like.
I like that.
Figure it out.
Yeah, figure out what the arc length is in that area. That's actually kind of a fun idea. Why didn't I think of that? I'm a day behind, aren't I? Yeah, I know. No, I'm just like busy. Track's keeping me crazy busy.
Yeah.
Yeah. Yeah. Okay, you guys ready for the last one? So, all right, David and Goliath, right? David's going. So, it's going 15 revolutions for every 10 seconds, right? Okay, so the question is, how fast is the angle going? So if it goes within 10 seconds, right? So what's the revolution? Well, we know it's going to go, watch. We know it's going to go 2 pi is my angle, right? It's going to go 2 pi, but how many times is it going to go 2 pi? I mean,
15.
Right. So the angle is actually pretty easy. The angle, theta, is going to be my 2 pi times my 15. Does that make sense? Or think of it this way. It's really easy if you think 360. I'm going to go 360 degrees, but I'm going to go around 15 times. But degrees for dummies, right? But you say, okay, how many degrees are you spinning? Spinning, I'm getting dizzy, I'm getting dizzy, right? So how many degrees would I spin?
360 times 10.
Right, or times 15. But I'm not going to use 360 because degrees for dummies, right? So we're going to do 2 pi times 15, and we get 30. We get 30 pi radians for every 10 seconds, right? Now we could probably reduce that, right? So we could really call that what? 3 pi. We could probably call that 3 pi radians per second. And radians are angles, right? It's so much easier in degrees. We understand degrees. But the reason we do radians is it has to do with the arc length more than anything, okay? So then if we want the linear speed, okay, if we want the linear speed, we know we're going to go 30 pi times around, okay? But how long is the radius? How long is the radius? 15, right? So, no, what's the radius?
Yeah, that's the. I don't think it's in there.
I didn't give you the radius. All right, give me a radius. What do you think?
I'd say 4.
4? How about 4? Well, it's got a sling. We do it in terms of what? I don't know. What do you guys think? Want to do it in feet? Let's do it in feet. So, okay, David How big? What do you think? Maybe 2, 3 feet? 3, let's give it 3 feet, because that rock's going to go even faster, right? So let's say the radius, the rock radius, let's go 3 feet, okay? So times 3, because that'd be the total circumference, right? It's going to go around 30 pi times. Okay, think about this. It's really actually pretty easy. Take a wheel, roll it, roll it, roll it, roll it, roll it, roll it. So it's going to go how far? It's going to go 30 pi times the 3, right? So that means it's going to go 90 pi feet in 10 seconds, right? Which would just reduce to 9 pi feet per second. Now that's moving pretty fast, actually. That rock is moving pretty fast. Because you figure that's 3.14 times 9. So it's traveling about 30 feet a second. Think about that. That rock's going about 30 feet a second. Yeah.
Yeah.
Yep. And I reduced it right, but yeah. Okay. Yeah. Okay. Homework. Josh, it's not that much, honest, because most of it's just these conversions. So here's the trick today. Here's the trick. Make sure you have your formulas, right? Got to have your formulas, and then the whole thing is not so bad, right? Okay.